Hello to anybody who might be listening to this. My name is Tristan Goh, and today I will be talking about the intersections of lines, two planes, and three planes. Without further ado, let's get started. As you can see right here, me and my partner Zicheng have created upon a slide for the intersections of lines, two planes, three planes that can help you more or less understand better. Right here is a table of content in which is all the subtopics. For my case, I will be talking about the intersection of lines in R2 and R3, the intersections of lines and planes in R3, the system of equations, and the consistent and inconsistent systems, while my partner Zicheng will be talking about the intersection of two planes, intersection of three planes, the distance between two planes, and the distance between straight lines. Currently, this video you're watching right now, I will be talking about just the intersection of lines in R2 and R3, and the intersections of lines and planes in R3. If you want to find out more about the system of equations and the consistent and inconsistent systems, please look at my next video. Anyways, let's get started with the subtopic intersections of lines in R2 and R3. To help you guys understand better, I will divide this into two parts. So let's first talk about the intersections of lines in R2. As you can see, as like how I listed below, there are two possible ways between two lines. The first one is a parallel, and the second one is the intersect at one point. All right, so first I'll be talking about parallel. As you see just now, here is a diagram of what a parallel should be like. So first thing we do is to check on the direction vector. So let me just give you an example right now. Line 1 is basically x, y, which will equal to 1, 4 plus t, 2, 3. And line 2 will be, let's just say 3, 7 plus s, 2, 3. As you can see from this line, we can tell that both line 1 is parallel with L2. So here's another thing to note. The question is not done yet. Let's just say line 3, x, y, equals 4, 5 plus k, -2, -3. So would you also say is line 1 and line 3 parallel to each other? The answer is definitely yes. The reason for this is -2, 3, -2 and -3, I mean, is you could look at it as this picture where it's like this as I'm writing right now. So because it's like that, we can look at it like that way. It is definitely a multiple of 2, 3. So yeah. Moving on to intersecting at one point. Here's another diagram to show how intersect at one point usually works. It's usually two lines crossing each other at a point, which is like this. So the main point is to find the exact point on where they meet up. So the big question is, how do you find the point? The answer to that is true, and by using simultaneous equation. However, I have to give you a reminder on this. Make sure the two lines are not parallel to each other. Otherwise, it won't be intersecting at one point. It will be parallel, which is what it means. So, time to give an example. L1, like just now, x and y, will equals, we can say 3, 7 plus t 1, 4. And L2, it can be 1, 5 plus s 4, 10. So by looking at this, we can clearly tell that 1, 4 is not a multiple of 4, 10. Therefore, because of this means that line 1 and line 2 are not parallel to each other. So, like just now, how I said that we will solve this through simultaneous agreement. Let's show you how. Firstly, we'll divide the two lines apart from each other first. By doing this, we divide it by, we use x first, is 3 plus t1, and for y case, it will be 7 plus t4. And for L2's case, it will be x 1 plus s4, and for this it will be y 5 plus s10. All right, so we can simplify it first by putting the x's together and the y's together. So 3 plus t will equal to 1 plus 4s. So we simplify as much as we can first. By doing that, we can find that t will equals to 4s minus 2. All right, we'll leave it at that for now. Now, we'll just leave it there and it could help us later on. So now moving on to y, 7 plus 4t equals to 5 plus 10s. So by using what we found just now with the value of t, we can put it together. 4s minus 2 equals 5 plus 10s. All right, so 7 plus 16s minus 8 equals 5 plus 10s. Simplify further, we can find out that 6s will equals to 5 plus 8 minus 7 So 6s will equal to 6, and dividing each other, 6 divided by 6 equals 1. So we found out the value that, the value for s is 1. So we can go back to t now, because we know the value. We can calculate and find out the value of t. So now that we know that the value of t equals to 2 and the value of s equals to 1, we can find out the value of the x and y. 3 plus 2 bracket 1 equals to 5. And the value of y will be 7 plus 2, 4, which equals to 15. So ultimately, our answer is 5, 15. So that's more or less how you do intersect at one point. All right, moving on. I will now be discussing about part 2 of the intersections of lines in R2 and R3, which is now the intersection of lines in R3. As you can see below, there are 3 possible ways. Like just now with R2, the same possible ways are parallel and intersect at one point, which I was discussing just now. But for R3, there is also one more possible way. And as you can see below, it is called skew. All right, first I'll be talking about parallel. Basically, just like R2, it is about the same. And also, just also another reminder to, like earlier, to check the direction vector. Okay, but to show you the slight difference between R2 and R3 for parallel, let me give you an example. For example, L1, unlike just now, now there's also Z in X, Y, Z. So let's just say 1, 2, 3 plus T, 2, 4, 5. And L2, three, 0, 5 plus S, 2, 4, and -5. Okay, so to show you, basically the direction vector, it's basically, we can see that it's 2, -4, and 5. So as you can see, -2, 4, and -5 is basically just x minus 1, which makes it equal to 2, -4, and 5. With that knowledge, we can obviously tell that L1 and L2 are parallel with each other. Moving on to intersect at one point, just like before, like R2, how to solve it is basically simultaneous equation. So let me give you another example once more. L1, let's say 1, 2, and O plus T, 1, 1, 4. And L2 it can be 2, 6, 1 plus S 3, 2, and let's just say 13. All right. Like just now, we will split the thing between X and Y, but now we'll also add Z. So one plus T equals 2 plus 3S. For Y, it will be 2 plus T equals to 6 plus 2S. And for Z, it will be 4T equals to 1 plus 13S. So first, we'll just put Z aside. Now we'll work on X and Y like usual. T will be equal to 3S plus 1. And T also that's for X case. And for Y's case, it will be 2S plus 4. So like just now on how we do simultaneous equation, just on how we'll do simultaneous equation, 3S plus 1 equals to 2S plus 4. Simplifying it, it will be S equals to 3. And by adding the value of S, which we just found, into one of them, the answer will be 10. And seeing for Y2, the value will also be the same. So by using this knowledge which we found of S and T, we move back to Z. We can now find that regardless of the answer, Z has exactly the same values with one another. So we can make a conclusion that X, Y, and Z have the same values. All right, so using what we found just now, which was S equals to 3 and T equals to 10, we can go back to what we had at the beginning, which was X. 1 plus 10 will equal to 11. Y will be 2 plus 10 equals to 12. And for Z, it will be 4 times 10, which will be 40. So the final answer for this example would be, for the where all 3 points meet, would be 11, 12, and 40. So yeah, here's an example of what a simultaneous of intersect at one point would do. And how do you do it is simultaneous, just like R2 and just like R3. They're exactly the same. All right, the final possible way to do R3 is through skew. However, as you may not know, skew is only an occurrence where there is no, it cannot be parallel. The reason for it not being parallel is because due to having all right, for the final step, it is a process called skew. Skew is only possible in a scenario where parallel is where it is not parallel, and it is also not an intersect at one point. To find out whether it's not a parallel, you need to check its direction of vector. And for intersect, you need to check whether x, y, and z are the same or not. As I mentioned earlier, these are the things that you can check in order to ensure whether it's a parallel or whether it's an intersect. But if it's neither, then it's a skew. Then once again, I'll give an example. So example, line 1, x, y, z equals to 1, 2, 0 plus t, 1, 1, 4. And for line 2, let's just say it's 2, 6, and perhaps 4 plus s, 3, 2, 13. Okay, let's split them all up by x, y, and z like usual. X, 1 plus t equals 2 plus 3s. Y will be 2 plus t equals 6 plus 2s. And for z, it will be 4t equals to 4 plus 13s. Okay, so let's concentrate on x and y first, like just now. T will be equals to, simplifying it, t will be equals to 10, and s will be equals to 3. All right, so how I got t and s is through simultaneous equation. So now, knowing the values of t and s, we can sub it into our z. So for t, which is 10, will equal to 40. And then for 4 plus 13s, which s is the value of 3, the answer is 43. So looking at the two different answers below, it is clear that the answers are not the same for z. So it means that the lines are clearly not intersecting with each other. That's what makes skew. Right. Moving back to the slide, I'll now be discussing the next subtopic, which is the intersections of lines and planes in R3. As shown below, there are 3 possible ways it can be done. First is through the line intersecting the plane. The second one is the line is parallel to the plane. However, it is not on the plane. And the third and last one would be the line being on the plane itself. All right, so the first possible case, which is the line intersecting the plane, there isn't much to explain, so I will just give an example. The line would be x, y, z, equals to -1, 3, 4, plus t, 6, 1, -2. So the equation of the plane would be x plus 2y minus z equals to -29. So from the line, x equals -1 plus 6t, y equals 3 plus t, and z would be 4 minus 2t. So how do you solve the width? It is through substitution. So substitute x, y, z into the plane. So seeing the values of x, y, z, substitute them like what I'm doing. And then through working, you find out, you continue to simplify it. And then you find out that the value of t would, and then you'll find out that the value of t would be equal to simplifying the equation, we will find out that the value equals to -3. So now we go back to the xyz equation by substituting the t into the equation. We can find out each value for x, y, and z. So with that, we now find the answer, which is -17, 0, and 10. All right, so now for the second case, which is parallel but not on the plane, I will again show an example of how it should be done. For example, line would be equal to 1, -2, and 1 plus t, 2, 5, and 4. So the equation on the plane would be 2x minus 4y plus 4z equals to 13. So with that, we can separate x, y, and z. So firstly, x would equal to 1 plus 2t, y would be -2 plus 5t, and z would be 1 plus 4t. So we can knowing these values, we can once again put them into the main equation, the equation of the plane, basically. So 2 times 1 plus 2t minus 4 times 2 plus 5t plus 4 times 1 plus 4t equals to 13. So simplifying the calculation, it's 14 plus 0t equals to 13. However, since we know that it's 0t equal to -1, the value for t would be -1 over 0. However, that cannot exist. So we will end up marking it as no values. We'll end up marking it as no values. So in conclusion, L and the equation of the line and the equation of the plane does not interact. As the reason for that is because they are parallel. So yeah. All right. So for the final case, which is case 3, will be the lines is lying on the plane itself. So time for another example. The line, we can, like usual, x, y, and z would be equal to 4, -3, 1 plus t, 14, -5, and -3. So the equation of the plane would be x plus y plus 3z equals to 4. So like usual, we separate the x, y, and z. 3, x is 3 plus 14t, y is -3 minus 5t, and z is 1 minus 3t. So we, like usual, we do simultaneous equation. 4 plus 14t minus 3 minus 5t plus 3, 1 minus 3 times 1 minus 3t equal to 4. So simplifying the equation, 4 plus 0t would be equal to 4. Hence 0t equals to 0. So due to it being 0, this ultimately means that the value of t can be anything. So this means that the line is lying within the equation of the plane. This is basically an example of the lines lying on the plane itself. All right, that's about it for this video. If you would like to know more about the system of equations and the consistent and inconsistent systems, please look at my next video. Good luck with the homework and assessments. Thank you and goodbye.